This Zoom session is being brought to you by the Fractal Heart of Gold. Okay. All right. This section 5.3 is about partial fractions. The next one, 5.4, is about nonlinear systems. A bit of a grab bag, but so be it. Partial fractions is something you'll be seeing actually mostly in calculus. When we're trying to integrate, say, this partial fraction, this rational function here. And it's easy if you could break it up into two pieces, because the integral of this is a logarithm, as is the integral of this. Whereas this, it's not so obvious. So, okay, so this can be written as a sum, a over x minus 1 over b plus b over x plus 1. And a and b are unknown. Turns out there are constants a and b for which these are identical. They're for the three lines. Here's the trick. We multiply through it by the common denominator. This x plus 1, x minus 1 cancels, leaves a 2. For this term, x minus 1 cancels, leaves an x plus 1. For this term, bx plus 1 cancels, leaves an x minus 1. 2 equals a times x plus 1 plus b times x minus 1, identically equal. Then we expand it a bit and get 0x plus 2 identically equal to a plus b times x plus a minus b. Since these are identical, they're true for any values of x. And well, actually, there's two approaches. One way is just to identify the coefficients. 0x plus 2 is identical to a plus b times x plus a minus b. So 0 equals a plus b, and a minus b is 2. A plus b is 0, a minus b is 2. After a very small amount of algebra, a is 1 and b is negative 1. So 2 over x minus 1 times x plus 1 equals 1 over x minus 1 plus negative 1 over x plus 1. So this is called a partial fraction decomposition. Now, okay, from here, I could instead have proceeded by using values of x. If x equals 1, then this term cancels and get 2 equals 2a, so a equals 1. If x equals negative 1, then this term cancels and 2 equals minus 2b, so b equals negative 1. I think a little easier in some respects. Now, if the denominator has a repeated linear factor, 2x minus 3 squared, we, instead of just using a over one factor plus b over the other factor, it's going to be a over 2x minus 3 plus b over 2x minus b squared. So you go up for the 1 in second power. If you multiply by 2x minus 3 squared, you get x plus 4 is identical to a times 2x plus 3 plus b. And okay, we could identify coefficients or use values of x. I think it's easy, just as easy to use values of x. We set x equal to 2, then you get 6 equals a plus b. And set x equal to 1, we get 5 equals negative a plus b. 6 equals a plus b, 5 equals negative a plus b. After a very small amount of algebra, you get a equals a half and b equals 11 halves. So x plus 4 over 2x minus 3 all squared is identical to a half over 2x minus 3 plus 11 halves over 2x minus 3 squared. So in the calculus, if you're supposed to integrate this, then you have to find it's the integral of this plus the integral of that. Now, here we have a denominator with an irreducible quadratic factor, x squared plus 1. So what we do in this case, okay, this is also an x squared factor. So you have an x factor and x squared factor underneath a and b. For the irreducible x squared plus 1 factor, we'll put it underneath cx plus d. So now we have numbers a, b, c, and d defined. And okay, so x squared plus 2 over x cubed plus x squared equals a over x plus b over x squared plus cx plus d over x squared plus 1. So okay, the trick is to find a, b, c, and d. If we multiply throughout by x cubed plus x squared, on the left you get x squared plus 2. This term gets x times x squared plus 1. This term becomes b times x squared plus 1. This term becomes cx plus d times x squared. And after a bit of rearranging, x squared plus 2 equals ax cubed plus b plus dx squared plus ax plus b. And so identifying coefficients. Oh, did I miss something? Oh, this should be an x plus c. Oh dear, I have to change that in the canvas. This is page 4. Okay, page 4, a plus c, x cubed. This should be an a plus c x cubed. So a plus c equals 1 equals 0. B plus d equals 1. A is 0. B is 2. And after a little bit of work, a is 0, b is 2, c is 0, d is negative 1. So x squared plus 2 over x squared plus x equals 2 over x squared plus negative 1 over x squared plus 1. So, okay, here are some examples. Well, for one of these, they simply ask you to write the form of the partial fraction decomposition and not find the coefficients. So I'll do one like a number 7. X squared over x minus 3x squared plus 4 is identical to what? Well, okay. The form will be a over x minus 3, because that's one factor, bx plus c over x squared plus 4, because that's an irreducible quadratic factor. Here, let's decompose x plus 14 over x squared minus 2x minus 8. First, we rewrite factor the denominator. X minus 4 times x plus 2. That's fairly routine. Underneath x plus 14 equals a over x minus 4 plus b over x plus 2. What are a and b? All right, starting from here, we multiply throughout by the common denominator. The left becomes x plus 14. The right becomes a times x minus plus 2 plus b times x minus 4. Now, okay, for this one, I think it's simple enough to use use values of x. When x is 4, this term vanishes. You can get 18 equals 6a. When set x equal to negative 2, this term vanishes and you get 12 equals negative 6b, from which quickly follows that a is 3 and b is negative 2. So x plus 14 over x squared minus 2x minus 8 is identical to 3 over x minus 4 plus negative 2 over x plus 2. And that's done for that. You have x minus 3 over x cubed plus 3x is identical to what? Okay, first, we factor the denominator. X times x squared plus 3. This x squared plus 3 is an irreducible quadratic factor. This should decompose into a over this x plus bx plus c over this x squared plus c. Find a, b, and c. Okay, first we multiply throughout by the common denominator. Get x minus 3 equals a times x squared plus 3 plus bx plus c times x. So let's go by coefficients. This on the left is 0x squared plus 1x minus 3. This we expanded out as a plus bx squared plus c times x plus 3a. So identifying coefficients means that a plus b equals negative. That a plus b is 0, c is 1, 3a is negative 3. So from that, easy to solve that a is negative 1, b is 1, c is 1. So x minus 3 over x cubed plus 3x is identical to negative 1 over x plus 1 over x squared plus 3. Okay, for this one, I solved by identifying coefficients. Let's see. For this one, I solved by values of x. Both should work. Okay, that's so much for that. That's